Hi, welcome to our third video in our video series on how to design with the Maven wireless nebula platform in iBwave. In our last video, we learned how to set up the head end and signal source using the Orion master unit and RBM cards. Today, we're going to have a look at the remote side and learn how to connect those up while keeping in mind some of the intricacies of the Maven platform and how they work specifically in iBwave. Before we get into all that in too much detail, though, I want to just quickly show you the Orion master and the Stratus remotes in a bit more detail. First, on the Orion Master, if you have a look at the optical interfaces on the left-hand side here, you'll see that there are 4 QSFP plus slots in total. Next, if we have a look at the Stratus remote, you'll see that there are 3 QSFP plus slots on the right-hand side and 4 SFP plus slots on the left. Now, if we compare that picture to what we actually show in iBwave here, you'll see that each of these connection points are doubled up. So you look at the optical interfaces on the Orion here, and then the optical interfaces on the Stratus, and you'll see each one of those QSFP plus interfaces and SFP plus interfaces are actually doubled up. The reason for that is because in iBwave you only have unidirectional sort of signal propagation from a source to a destination port. So in order to give the kind of bidirectional flow that is sort of intrinsic to the Maven Nebula platform, we need to double up each interface like that. So it's important that we sort of have that in mind before we start wiring up all of our remote units here. And next, we'll have a look at the Stratus units in particular in iBwave. First, having a look at this unit here on the left. I'll double click on it just to sort of double check what it is. So we can see here, this is a model RHN000050, and that is a quad band Stratus that covers 800, 900, 1800, and 2100 megahertz bins. So a key here to pay attention to is the type. So the type here is media converter, and that is going to be true for all Stratus remotes, not just this one. And it's a key facet of sort of that determines how the unit behaves and how to get it to work in iBwave here. So first things first, we can have a look at the interfaces and start to connect them up. So we go out to in the first instance. And if we remember a little bit of what's actually going on here, what this is going to actually be doing is it's going to be carrying signal from the signal source here through this card here, which is attached to the chassis, and then out of this port here, and then carrying the signal to this guy here. What you can see though is there's nothing actually displaying at the port. We should be seeing something because we've got our calculations sorted here. So this is where the media converter bit comes into play. So if we right click and we say associate media converter with systems, click here, click path 1, and we can see we have our signal being reported here. So this is, I believe, our RSRP for 1800 megahertz from EE here that we've set up on path 1 specifically. Okay, and now we can start connecting up our remote units. So first things first, we go from out to in, from the master unit to the remote, then out to in, from the first unit to the second unit. And what these actually are, this will be our MIMO A unit right here. So we'll see this is an RHN50, and then we look at the second type here, and that's an RHN50 as well. So this will be our MIMO B. And we've got paths to everything. Now, first thing we notice here is there's a little bit of an issue, or it looks like there's a little bit of an issue. So we can see we have our RSRP calculation represented for this 1800 LTE service on both paths. We see everything sort of propagating through here, but we don't see anything coming out of the end at the remote units here. The reason for that is because, as we mentioned before, these are modeled as media converters, not FPDAs, which is sort of the typical remote unit in the iBwave that you encounter usually. So first thing we need to do is to associate the media converter with systems. So the way that you do that is you just right-click on the unit itself, and you select the service that you want to propagate. So we've selected path 1 here, And this has immediately done something a little bit odd. So this has put path 1 to the first unit and also the second unit here. Naturally, you're not going to want that in reality, so you're just going to want it on the first unit. So what we're going to have to do here is to deselect path 1. And then we have something that's a little bit more accurate. But there is actually a slight problem that we have here. So the issue is that when we go to associate a media converter with systems on the second remote here, we do not have path 2 available. The reason is that we don't have it selected in the first one. So this is a little bit of an idiosyncrasy. So what we can do to get it to pass is to select path 2 there. So that is now active in this first unit. And we go to the second unit, and we select path 2. So now we have something that looks a little bit more correct. So we go first at our path 2 here, and we can see we're getting signal out of this unit. That's perfectly fine. We look at this unit here, and we notice something a little bit odd. So not only do we have path 1, but we have path 2 out as well. So this is something where it gets into a little bit of the weeds of how to get the Maven wireless system to work well in iBwave while sort of still using all of the available features of the platform itself. So there are some workarounds to this. The easiest one would actually be to go ahead and disassociate the first unit with path 2 entirely. And then we make a temporary fiber optic run from here back to our master. We'll try that again. Go that way. Okay, so let's have a look here. We have path 2 out, and we have path 1 out. Now, the critical thing here is this is not actually necessary in how we implement systems in the field. In reality, all that you need is this. So just the single fiber going from here to here to here. But in iBwave, we can't do that. We have to have a second source coming through. So another way of doing that might be actually something that's a little bit more realistic, something that we might see more in the field, is doing it this way too. So you have your A path coming here. We do have an interlink here for redundancy, and then we have our B path coming here. So this is what you would call sort of a ring topology, and that's actually something that you might actually see implemented and might want to utilize in the field, because with ring topologies, they are quite resilient. You have fiber optic redundancy. The fiber optic redundancy isn't really apparent in iBwave in terms of how it actually works. As it stands, we're not actually using this fiber, and we're not actually using this fiber when it comes to what's actually being modeled here in iBwave. So I hope that makes sense. We have a few more aspects to go into on this, but this is a good one to chew on and to try for yourself to get you started. That's it for this video. In our next video, we'll be going into different fiber topologies and some more complicated sectorization and MIMO scenarios.